sorry. Oh, okay.
He says, yeah, get out of here.
So last night, I had taken him with me some hours. I had him kind of hold his nose. I got out of the truck, and my husband has a big, I don't get that, and it's like dark, pitch black, and I was trying not to stand up crazy. So I grabbed it, and it slammed it shut. And the handle was in
You're not taking our donuts, are you?
Just one.
I already offered it to them when they came in and got what they liked.
We get protective on those.
Well, I already told those two they can have me down.
Back.
And of course, I was braced here, so I didn't have any gear.
Oops, they did bring one there. That's all right, when I get here early, yeah, it's sale day. I used to know it.
And then I was just like,
Quick.
and they were saying,
What's wrong? I'm like, did you see the forecast? We're getting snow tomorrow through for a week.
We're supposed to get all
Tonight and night. We're still climbing the mountain. We're down there.
right
Right
now,
now.
yeah, it was always.
Yeah, we're supposed to get snow all week next week.
Yeah, we're just gonna have to bundle up. There's 3 this morning.
Oh my.
If this was bad as the other day, I would come in.
It's like 17. Like,
I'm
it's
just
cold. It's cold. Where is that?
You guys that are traveling, use good judgment. Roads are crappy.
Past,
Hopefully you got a cat at home. You can watch your video.
Yeah.
Don't risk your life to get here.
I hate missing because of the weather.
I know, no, I like being, yeah. Like I said, I give myself 2 hours. If I'm not here, they're calling. No, I mean, I would let someone down.
Well, the other morning, I couldn't see 5 feet in front of me.
No, I had-
That's how bad it was.
Just, yeah, when it was blowing, it's like, it feels like you can't. That's okay.
Not to mention all the accidents on the way.
Yeah, sometimes, you got 85 miles an hour, I mean, it's bad enough, we might
Yeah.
just slow down to 45. I mean,
Yeah.
so,
All right, let's get started. I'm not waiting any longer.
All right. Yeah, we got lots to do.
Yeah, we-
Thank you. Yeah.
All right, so I gave you the last 2 assignments and I want to explain these now. I think some of you are probably ready for assignment 5, which is the one I've got up on the overhead. I wanted to give you number 6 too, which will be your last one, because I want you to start thinking about it now. And I think we'll probably get this one, I'm hoping you're started on it by approximately next Tuesday. Now keep in mind that this class, I hope to have it done by a week from today and testing on it, but you're gonna have a couple extra days to draw after that. We will start architectural drafting on the following Monday. You need to have that architectural book. If you don't have it yet, get that thing here, because we will have a few days of information before we can really start drawing. Okay? So you'll have a little bit of time to work on that last project also. All right, so this is really kind of a nice project, and I think it ties this whole thing together on solid modeling. Okay? And it puts it into a sense that many of us will end up working in this arena. So this is a real life type of situation. In fact, people are doing this today out in Twin Falls. Okay? As part of getting paid for it, which sorry to say you're not, but we give you a good practice at it. All right, now I tried to explain quite a few things here. One thing, you're going to have a bunch of files that you are managing together. So I would highly recommend that you do a little sorting on your hard drive. Create a directory for all this stuff's going. Okay. So I've got on mine, I've got a directory called draft, or a file folder called draft 149. Underneath that, I'm going to create another directory and call it butterfly valve. And all of these files that I use are going to be stored in that directory, because you're going to have to use these files together. Now, when you come through, we're in essence going to have a drawing set that's done in a mechanical sense. When you put together a machine in the mechanical world, what you do is you have a drawing set that shows how it's done. The first drawing in the drawing set is an assembly drawing, or shows how all these parts fit together so that somebody can assemble the project. Following that, we have what are called detailed drawings, which are usually standalone multi-view drawings that we can rip out of the package and hand to a craftsman and they can build that part. Okay. So you've got first one's in assembly, and you might have sub-assemblies in assemblies because the assembly process might be fairly complex. But you'll have something showing how it all mates together, And then you'll have the building information in sheets that follow it. And these can be very extensive. I mean, think of a car engine. The drawing set for a car engine is probably easily 1,000 pages of nothing but drawings. So many sub-assemblies and assemblies. Now this one, we're just going to do a valve. So we can do all this in one part. So you're going to have first, I'm right here in this methodology. Your drawing set's going to have two sections. It's going to have an exploded assembly drawing, which is going to be one drawing. Then you're going to have a detailed drawing, which shows how to construct all these items, and there's going to be 5 of them that are required. Okay. Now, when you're critiqued on this, the assembly is going to be graded as one drawing. All of your details are going to be graded as one drawing. See? So that's how I'm going to throw it in the grade book. You're going to get 2 grades for this thing.
You're gonna turn it into 6 pieces.
What's that?
You're gonna turn it into 6.
You're going to turn in 6 pieces that are stapled together. Alrighty? Now, let's talk about the individual sections. First, your assembly drawings on page 999 of your Bertolini text. And then the details are on the next. Now, there's some different information down in here that I'm going to come off the monitor with, but we're going to go to the figure here. Okay? So the assembly drawing will look similar to this right here. Now there will be a couple things different that I ask. Number 1, your parts list. This is in a bad spot. It goes with the title block. Okay, so what I'd like you to do is when you do your parts list, I want it down here because our title block's along the bottom for a B sheet. Put it in the bottom right hand corner right above your title block. We're going to do the exploded assembly, which is this portion right here. Okay. Now this drawing also has more of an isometric view and what's called a section assembly on it. You do not have to do those. If you want to, it's just a couple clicks. Okay? But don't make your page unreadable by giving them this stuff. If it enhances a drawing, do it. If it doesn't, don't worry about it. This exploded assembly in an isometric orientation is what we're looking for. There's center lines on here showing how all the parts go together. Those are going to be drawn in paper space. You will have to do your bugs. We call these things bugs that go on here. They are done wrong on this. Number 1, they're not pointing to edges. Okay, so follow our standards. Okay, so if you're doing one, it should come off of an edge and it should have a shoulder. And then we generally put that little circle there and we put our part number right there. This part number goes into this, which tells you what it is. So part 5 is a Woodruff key. And so of course you'd want to point to the Woodruff key. Now, many times this will have another column on here saying what page the detail drawing is on. But there's also going to be something that goes. Now, this Woodruff key is a standard part. We're buying it from a vendor. So it's shown here, but it's not shown in the others. And we'll get into more of that in a minute. In essence, this is your drawing. Okay. Now, if you look down below on required parts for detailed drawings, you see that in bold right there? Following that, you're producing solids of parts 1, 3, 4, 6, and 8. Okay. So you're doing this guy, this guy, this guy, this guy, and this guy. I think I got them all. This nut that screws on the end of the shaft is extra credit. If you want to do these 3 bolts and these 2 screws, they're extra credit. Okay. The Woodruff key is extra credit. And that's listed down below. You'll find out actually, I give you 1 extra credit point if you do the bolts and the screws, 1 for doing the Woodruff key, and I don't give you any for the nut. But it's good practice. All right, so those are going to be the required ones. We're not doing everything on here in the interest of time. but we're gonna do the major parts. Now, I have altered the parts just a little bit, also in the essence of time, and to correct some mistakes in the text. When you're doing your detailed drawings of these parts, if you go to the next page, here is all your dimensional information. Now, if you don't know what a butterfly valve is, let me just kind of real quickly explain what's going on. This is the housing. We're going to have fluid or air coming this direction. That goes through. There's a pipe attached here that heads off. There's a pipe at the bottom that goes somewhere else. You've got a shaft, this guy, that fits in this hole. That shaft has this thing bolted on right here. Okay. This thing right here, when you turn it down, will cut that flow off right in here. So in essence, you stick the shaft in, you put the handle on so you can move it, and all you do is you're rotating this thing up to let fluid through, down to shut it off. Okay. What we call a butterfly valve. The retainer up here gets bolted on right here and it holds the shaft in place. That's what it does. I think everything's pretty straightforward on here except for this. This has a couple mistakes on it. And I've listed these in your details, but I just wrote them right on my drawing if you want to write them here. First off, this overall length is not right. Got a heck of a glare on here, don't I? Is that easier to see? Okay, that 3.898, it's not even close to being right. And in fact, if you add up these dimensions they give you for the length, you're going to get 3.95 just to there. And then if you try and put it in your housing up above, it's sitting out in the end, it's sitting there wobbling. It's not being held on the other side. Use 4.198. What that does is it gives you almost a 1/4 inch that sits in the housing to hold the back end. The reason it isn't 0.250 is because we wanted 0.02 of slop to make sure it fits. The Woodruff key, which is extra credit, if you wish to use this, use an 1/8 inch by 3/8 size. And how to draw it is in Appendix 54. That's also in your information under extra credit. When you change this, when you change this height or length, the only thing you're changing is this right here, okay? That doesn't affect any of this dimensional information for placing this stuff.
Can I just, what does the Woodruff key thing do? What is it?
Woodruff key holds the handle onto this shaft right here. The handle slides over this piece right here, and then that nut screws on to hold the handle. Now, when you turn the handle, you got to link this shaft to the handle.
Yeah.
A Woodruff key is a little half-moon shaped key that slides in where I don't have access to come in from the side.
Oh, so that's what's that key right thing?
Yeah. Declan, you told me at one time you think you might have some of these.
I think I have one, yeah.
Is there any chance you could bring one in and we don't have to keep it, but maybe just show people? I don't have one here.
I can go look and see if they still have it.
Okay. If you can't, let me know and maybe I'll swing by Ace Hardware somewhere and grab one.
Okay.
I do have a shaft that's set up for a Woodruff key already.
That's permanent in there. What is that Woodruff key?
No, it's for maintenance. That's why we use keys. We can take it back apart.
But I mean, it's inside the shaft, but it's attached.
This
to the
engraving is part of the shaft. Yes, that's permanent.
Okay.
Now,
I mean,
here's,
you can replace it.
get down into your details on this. There's a couple things. You're not doing the Woodruff key unless you wish to do it for extra credit. So therefore, you don't need to do this slot in the shaft. Because if you're behind schedule on time-wise, I want you to finish the project first. Now, if you're going to do the extra credit key for the Woodruff, it's a pretty simple thing to slap it in here and subtract it and get the shape. So you can't put that in unless you draw it anyway, so it's not required. It's extra credit. The threads are not required, they're extra credit. And in fact, I don't even really want you messing with this one, I'd rather having you doing the screws and stuff first. So just take this, use your major diameter, it's a 3/8. Here's your thread note. Just take it and draw it at 3/8 and leave it a solid piece without any threads on it. The same with up in the body. The body has some internal threads on it. Up in where these holes go in, right up in here. Just use the thread diameter and make them cylinders. Okay, now also on the details. Remember, each one of these are going to be one drawing file. So you're going to open a template, have this, model it. That's the only thing in that file. Shut it down once you're finished. Start a new drawing, model this. Save it, close it, start a new drawing, do this. You're not putting all these into one drawing. Okay, so don't just do one drawing and start modeling away. The reason is it gets to be a pain to print these things and put dimensions on them if you got a bunch of models you're dealing with in one drawing. So generally they're done one drawing per file. Okay. You are producing the multi-views of all of these parts for construction. You are not annotating any of them except for one. You're going to annotate this one. Wait, which one? Did I do the retainer? Which one did I ask you to annotate? What? The retainer? Okay, thank you. This one. I tried to pick the one that would be the easiest to dimension. And this is again in the interest of time, right? It would take us a substantial amount of time to produce the multi-views and dimension this. So you're producing the multi-views of every single part. Scale's left to you, but you're doing the full working drawing on this one and this one only. Okay. Does that make sense? Now, once you finish these, then you've got about maybe a 20-30 minute operation to create your assembly. You're going to take all these drawings and XREF them into one drawing. Apply them in an isometric sense so that you have the exploded assembly shown. In essence, you don't draw the exploded assembly. We're just XREFing all these drawings into one and displaying. Let me kind of give you an idea of how this is going to work. Okay, so in essence, here's my file folder right here. Okay, if I jump into that, here's all the different drawings that are going with this project. Now, I've got most of the extra credit drawn in here, so there's more than what you might have. You're going to have 6 drawings at a minimum for the whole project, 9 at a maximum. So in essence, if I come down, here's one of the drawings. Okay. So here's the valve assembly. Okay. And it's drawn in its entirety. Now, one thing that might help you is picking the correct front view for these. Because I've got to dump all these into a drawing that I'm going to show how it's put together. So I chose looking down the length of the shaft as my front view for every part of the drawing because it's all sitting on there. So that way when I XREF them in, I just slap these to a front view, drop them in a drawing, and they're already all aligned. I don't have to do any moves and rotates and all that stuff. Okay. So do this as a whole. So here it is. This little hole in the back, this is the part for that shaft that we had to change the length for so that it holds in the back. And that dimensional information in the body is correct. It's not correct on the shaft. That's why we changed that. So there's one drawing. Here's another drawing. This is just another, again, solid drawing. And all you're going to do is make all these drawings. If you decide to go for some extra credit, okay, there's our Woodruff key. If you want to do, here's my little pan head, guys. Here's my retainer. Now again, you're going to dump, this is the one you're going to do the completed finished drawing on. So you're going to dump this into view base and then draw all your center lines and dimension this one. Let's see if I missed any parts. Oh, my shaft. Okay. So here's the shaft and its orientation. Now this one I went and put the Woodruff key in. Notice that I don't have the threads out here, things like that. So this is in essence your finished project. So you're going to have these drawings, do view base on all of them, as many views as they require, just don't annotate them except for the retainer. Now once you're done with that, let me close a bunch of these off. You're going to then use XREF to throw these things in. And let me open that drawing, I got one more to show. Okay, so here it is sitting in model space. Now, all I did is dump these in on one plane. I dumped all these in at 0, 0. And then I went to my right side view and then just started sliding individual ones out. And that's the beauty of having it on the front one and dropping it in. And I can help you with this when you get to that process. Okay, because it makes it easy. So here it is in model space, where everything's kind of aligned. And you're going to have to play with it a little bit so that when you get to this view, and you got to be able to read it, right? I didn't hit F1. So if you set it in an isometric, okay, let me just choose one here. You want to make sure that you can see the parts that you need to, because if they're too close together, like this guy is maybe right here, now I start blocking things off, right? And it's totally up to you on how far apart these things go. You just want them to read well. Once you do that, then you're going to go to paper space. You'll set it in this orientation. You don't have to, but you can do it with view base. This just got view base on it. Turned off all the hidden lines because it's an isometric drawing. There are no hidden lines with isometrics, right? And then I just drew my center lines in. Okay. I haven't put the bugs and the title block in on this yet. I just started doing this project last year. But that's going to happen for my key. And I do that right here.
So the dimensioning of the retainer is only done on its main view, not it.
No, it's a 2-view drawing at the minimum.
I know, but we don't have to put the dimensions of the retainer on this view.
That is correct. There are no dimensions on this view. This is an assembly. Now, one thing I never mentioned, on assemblies, especially an exploded assembly, which is probably 90% of all assemblies, they are done in an isometric orientation with center line showing location. All parts for the machine are shown here. Now, you don't have to because you're not drawing these nuts and bolts and things like that. But if I was doing this in real life, I would do all of my parts. The details that follow the assembly that I do multi-views of are only the parts that my company is building. The other parts we call standard parts. I'm buying them from a vendor. I don't need to do a detailed drawing of a 10 by 32 UNF thread if I'm going to walk down to Ace Hardware and buy one. Okay, I do need to show where it goes in the assembly, but I'm not building it. So this is kind of how it works. On most assemblies, every part's shown, but you only do details of the stuff you're physically building. In essence, that is your finished project. If you do something in this orientation, I'll tell you what, Seastrom's Manufacturing builds these in town. Lang pumps, that's who I always used when I was mining. I used Lang right out of Twin Falls here, no matter where I was in the world. The Grundfos pumps are the best, and they're the distributor. They do this stuff all the time. There's several firms here locally that would do this stuff for you. Yes?
Center's on the center lines. So the one in the middle of the shaft, you don't have to see, you just have to extend through the handle, you don't have to, is there any?
You want to just kind of make these look good.
Okay, so you don't have to see the other side of the handle thing sticking out so far.
Yeah, I just
only
drew
in
it.
So far.
I just drew it from here to there, and then I just came in and started doing little lines and
Okay,
trimming
so
it
they're not
out.
standards, like it doesn't have to stick out 0.05 or whatever, it doesn't have to have any,
Right,
okay.
but it shouldn't go over the top of this.
Well, no, I know,
Yeah.
but it doesn't have to come out with the handle either.
Right,
Okay.
okay? Fun little project.
Yeah.
Fun little project. And to be honest with you, if you can do this and get it completely done just to our base minimums that we got, any firm in town will probably hire you that does this type of work. This was totally cutting edge 5 years ago. Now it's starting to move into mainstream. 5 years ago, there were very few firms that would do this. I think in the next 5 years, everybody's going to do it. But it's an advantage of doing it solid and using it in multiple formats. If you did all these 2D work, you'd be redrawing all these. This assembly used to be a flat drawing, drawn in isometrics. We've got the solid, we don't need to do that. And these are just X-Ref in, folks. Blank drawing. The only thing in here is those center lines right now. Everything else is X-Ref. Yes?
Can I ask you to do an example of the next rep again?
When you get
Let's go
there,
back to the-
give me a holler. And yes, before you do, I'd probably ask you to review chapter 30 out of the blue section.
Okay.
All right, now for the last one. Okay, so that's what you're going to have there. What many students think is the funnest project of the year.